Okay, and next I would like to introduce Lefteris Manasakis, who will be presenting Monitoring Root DNS Prefixes. Lefteris is a technical leader at Cisco and traveled from Greece to join us today. This is Lefteris' third time presenting at NANOG. Lefteris' first talk was called BGP Zombies, Ghost Routers as Seen by BGP Monitoring Platforms in NANOG 87 in Atlanta in the year 2023. Welcome back to NANOG, Lefteris. It's a pleasure to have you back with us today. Thank you. Please welcome Matt Lefteris.
Thank you. My name is Lefteris. I come from the island of Crete in Greece. And today I'm going to talk to you about monitoring root DNS prefixes, a project we started in January of 2023. We are a group of researchers from the island of Crete in Greece, three researchers, that we dropped research in late 2020. We were focusing on internet measurements and routing security. We started a startup mainly to learn more about the industry as an experience. We didn't expect that we would be acquired by Cisco in August of 2023. As I said, this project started on January of 2023. But before we talk about the topic, a few things that I think most of you or everybody knows. The border gateway protocol, BGP, is the glue that holds the internet together. And it's vulnerable to attacks for various reasons. Geoff Houston, who's a good friend, says something that I really like, that back in the day, in the late 80s, when the internet was being developed, we didn't expect the internet to escape the lab, which is quite cute to say, because the network was being comprised by research institutes, academic networks, and other entities that used to trust each other, essentially. So there was no need to embed security into the protocol. And as a result, we have a lot of security-related events that are around BGP, of course. A lot of things have changed since then, like RPKI, ASPA, and other things have been introduced into the protocol, but issues still exist. And the other topic that we need to introduce briefly is the root DNS servers, who are the authoritative name servers for the DNS root zone. Essentially, they are the core of the DNS infrastructure. We have currently 12 operators using 26 root DNS servers, 13v4 and 13v6. And the question is, why monitor them? First of all, for a startup, this is something that I have not included in the slides. For a startup like Code BGP, a small startup from Greece, we wanted to detect events so that we gain some visibility and come to NANOG and present such stuff and get more visibility to what we do. But other than that, the root DNS server prefixes are critical internet infrastructure. Therefore, it's worth being protected. And our hunch was that since these prefixes are heavily anycasted, any impact on the data plane would be negligible. And therefore, this kind of events, exact prefix hijacks in particular, would go hardly unnoticed due to the nature of BGP being a path-hiding protocol, therefore hiding all the paths and propagating only the best paths. Origin hijacks would have only local impact, and they could go largely unnoticed on the data plane. And the question is, how can you alert on such events? It's quite straightforward. First, you identify the covering prefix of each IP. You identify the autonomous system that announces this prefix. And then you create a rule which says, if I see a BGP update that has as origin any other prefix other than, any other AES other than the AES that is supposed to announce this prefix, then alert me, and you are confident in this case that this is not a false positive. The only notable exception to this rule of being straightforward to create alert rules is VeriSign. VeriSign uses a unique ASN per node. It is described in detail in RFC 6382, what they do. The reason they do it is primarily for operational reasons. They want, for each AES they use at each node all over the world, they know exactly where it is located, so they can identify the impact on the local level as well. And they do it for operational reasons as well, as I have discussed with them. And here in this view, we see the visualization of A-root's announcement, which belongs to VeriSign. It's the .com domains. On the left side, we see the monitors that see all this, the A-root prefix. We have a number of hops that are being hidden in this view. And next, we see the core ASN of VeriSign, AS7342. Next, we see the hundreds of AESs that VeriSign uses to make this announcement from all the nodes. We see part of them, of course, not all of them. And on the right side, we see the V4 prefix of A-root. And now I'm going to start presenting the events we detected. Initially with the Code BGP platform, the platform we developed as part of our startup. We started monitoring on January 15, 2023. A few weeks later, we detected that AS24028 appeared as the origin of the V6 prefix of the Internet Systems Consortium. I must say that I try throughout the presentation to not name networks, but rather use the autonomous system numbers, because the goal is not to name and shame people. The goal is to raise awareness. And in most cases, if not all the cases that I detected, it was a case of misconfiguration and not malicious events. So appeared as the origin of the V6 prefix of Internet Systems Consortium, and the propagation of this announcement was very limited. Only one RIPRIS monitor was picking up this announcement, and this monitor was residing in Singapore. We had a collection of our own monitors worldwide, and also we were using the RIPRIS live dataset. And one RIP monitor was picking up the announcement. At the time, my assumption was that the reason this propagation was limited is because this V6 prefix is covered by an RPKI ROA. 1 month later, on February 25, 2023, another event took place that was slightly more interesting. AS17639, which is a network that has been reported multiple times, I must say, that has been involved in such events, appeared as origin again of the V6 prefix of the Internet Systems Consortium. On the same date, on the same time, exact same timestamp, the same AES appeared as origin of the V6 prefix of NASA, of VRoot. What is interesting about this event is that you see the difference on the real internet. It essentially serves as an experiment on the real internet. What is the difference between the blast radius of the propagation of an announcement that has an RPKI ROA versus it has not an RPKI ROA? Like eRoot does not have an RPKI ROA, and the blast radius of the announcement was 3 times larger compared to FRoot, and lasted multiple hours. If I remember, 18 hours the event took place. Can I go back? No, yes. Okay. On June 12, 2023, KRoot, AS201333, appeared as origin of the V4 prefix of RIPE NCC. I must say that for all these events, we informed the root DNS operators that we detected this event. In some cases, we never got a reply. In other cases, we got a reply, we're looking into it, but the event was taking place for hours or days. In this case, the good people of RIPE NCC replied immediately. They identified the issue. It was a host in Italy. This event was visible only in monitors residing in Italy, had a very local impact again. And they withdrew the prefix from the host because the host was stripping RIPE NCC's AES and was propagating the announcement. That's why it was an anomaly. They withdrew the prefix from the host, and the issue was resolved in a couple of hours. This event that took place in April 28, 2023 is quite interesting, and we will talk more about it. AES 137661, an Indian network, appeared as origin of the V4 prefix of ICANN, of LRoot. The first thing that was interesting about this event is that this announcement is propagated, was prepended 7 times. It had a total AES length of 11 hops, 7 of which were prepended. Therefore, it had a very limited visibility. It was being picked up only by one Code BGP monitor, again residing in Singapore. Interestingly enough, the super prefix of this prefix, the /23, also belongs to ICANN, and it was also being announced by the same network. And no RIPE or Code BGP monitor was able to pick it up due to the very long AES path. And I was able to see that only in looking glasses, such as the Aurelion looking glass that I have screenshotted here. So I noticed that, and I started monitoring the AES itself, the Indian network, to see all the announcements they make. So I was starting monitoring the AES itself to see what they're doing and why. Try to figure out what's going on. They were announcing multiple prefixes, but the only 2 prefixes they are propagated and prepended 7 times were the 2 prefixes of ICANN, which I found interesting. This Indian network had 2 upstreams. Another Indian network was picking up the announcement, was forwarding the announcement to AES 9498, which is Bharti Airtel, one big network in India. And Bharti was propagating the announcement to all their public peering points, essentially to all the places where they have IXP presence. And here is a snapshot from Link's Alice Looking Glass, where we see the announcement. The only notable exception was DECX. Although this prefix was not covered by AROA, they were blocking the announcement because they were using routing hygiene practices like checking route objects in IRRDB, and they were blocking the announcement because of it. And they were the only IXP who did that. And as I said earlier, this event was not detected by RIPE initially because throughout the timeline of this event, RIPE monitors picked up the announcement as well, but initially it was not being picked up. It was being picked up only by one Code BGP monitor. And this is a well-known research topic. Research has shown that carefully crafted hijacks to avoid detection by routing infrastructures is feasible if you only use public sources, because the hijackers know all the AES paths that exist in public sources. Therefore, they can avoid being detected by route collectors that are public. There has been a paper on this topic that I refer here, and the paper did simulations in order to prove this point, but there are actually events that take place that, not just theory, in other words, that verify that. So the company, Code BGP, got acquired in August of 2023. We stopped monitoring the prefixes because the Code BGP platform was decommissioned. But 1 year later, in June of 2024, we started monitoring again. I will drink some water. Sorry for the interruption. This has happened to me twice. I have done like 100 presentations, the second time that I need water. Anyway, the event lasted more than a year because 1 year later, we started monitoring the root DNS prefixes using the Thousand Eyes platform because during that year, we essentially embedded our technology to the Cisco Thousand Eyes platform, and we started monitoring, and I picked up the event again on the Thousand Eyes platform. And this is how it looked by the Thousand Eyes platform. The event was being picked up only by 2 monitors in India. And what is very cool now that we work with Thousand Eyes is that before, while at Code BGP, we only had control plane data. Code BGP platform was a pure control plane platform, essentially, only BGP data. We could only assume what's going on the data plane. But now we can measure exactly what's going on. And out of the 1,000 probes that exist in the Thousand Eyes platform, we call them cloud agents. Only 3 were forwarding DNS queries towards LRoot's prefix via the offending autonomous system. Essentially, it had a very local impact in India. And last event that I will present, with more data this time due to the fact that we're using Thousand Eyes. On June 20, 2025, again, LRoot was involved. A Peruvian network, AS3132, appeared as origin of the V4 prefix of ICANN again. The event was seen only by 19 monitors out of the hundreds of monitors that we have. And here in this view, you can see how the legitimate path is being withdrawn, the one with the dots, the dotted line, and is being, the new AS path is being introduced, the legitimate one. In the BGP updates table, which is essentially an export of the BMP protocol of RFC 7854, we can see that AS3356 Lumen is picking up the announcement and propagating it during the timestamp of the event. And now, as I said, we can measure also the impact on the data plane. And how do you do that for this specific measurement? Since we're talking about root DNS prefixes, the suitable test is a DNS test. Essentially, you use a domain, a .org domain in this case, since LRoot, among other domains, serves .org domains. Therefore, I picked up wikipedia.org. And I used as lookup servers the 2 IP addresses of LRoot, the V4 and the V6. And then you can create an alert rule that says, if you see this AS, 3132, alert me. And you measure from the 1,000 plus probes that we have all over the world. We call them cloud agents. Interestingly, out of the 1,000 plus agents, only 104 agents were propagating the announcement through the offending network. So we could estimate that the impact on the data plane was about 10%. Of course, this estimation is not accurate because the data set is very biased. We primarily peer with ISPs. This is not quite, it's biased. It's a biased data set. We knew that. We presented all our findings to the good folks of ICANN in an ITF meeting in Dublin 1 year ago or something. And they identified the event. Again, it was a misconfiguration. They withdraw the prefix from the host, the issue was resolved, and they measured the impact on the data plane, and because they actually have data from actual traffic that they're measuring, and the impact in reality was 3%. It was not 10%, but again, it was significant. To conclude, for the networks that haven't done it yet, please create your ROAS, because as I showed in the data, they actually protect from such events, not fully, of course. RPKI is not a panacea, but it helps for sure. And it's very easy to do, like all the interfaces that the routing registers have are quite straightforward. And secondly, of course, I'll say something that everybody knows, it's not news. In BGP, the more you see, the more you find. So there is need for quality BGP monitoring. Thank you very much for your attention, and I would love to hear your questions.
Jeff Houston, APNIC, thank you for that talk. That's very interesting. The issue about hijacking the route to a root server is not necessarily to give bad answers. It's actually to see what people are asking and certainly gaining control of a fraction of that root stream. You get to see a huge amount of information that you would not otherwise see or be entitled to see. Now, you've explained how difficult it is for all of us to protect those routes. There's a lot of them, and it's really easy to fake stuff in. That's true. That's the whole issue with anycast. What I think I'd add as a postscript to this is that if you're not doing in your BGP resolution environment as network operators, doing query name minimization, you're doing your users a massive disservice. Because what you want to do is not give the root servers the full DNS query name. You need to give it just the minimal name that can be resolved at the root and not leak extraneous information. Now, that doesn't mean I can completely ignore the issue of root server hijack. It doesn't. But it does mean that some of the collateral damage in privacy leak can be minimized by you and I at the edge by simply doing the right things with our queries. Thank you.
Thank you, thank you. You're very right, of course, and there is also other things you can do with that, like use DNSSEC, for example. I didn't go into this part because DNS is not my field of expertise. I'm more of a BGP guy. But of course, you're right. Thank you.
Wes Hardiker, Google, and actually also BRoot. So I actually oversaw BRoot for 10 years and then left for Google, and I still actually volunteer a lot of my time, and I'm still a part of the operations team there. We love research at BRoot. We actually pride ourselves, and that is one of our mission purposes is to do research. So if you ever see events that are affecting BRoot and you want to get to ground truth, please do reach out to our team. I will even say that most root operators, encourage contact. So if you want ground truth on why something might have happened and you need it from the other end, we might be able to help or not, depending on what it is. Jeff is right that, people do weird routes for various reasons. One thing that we noted, so at BRoot, we actually advertised 3 different address prefixes. Our oldest one from, I think, 8 or 9 years ago, I forgot the exact date. We just switched in 2024, 2025 to the newest one so that we can get under a different RIR. One thing I noticed in looking at routing things from afar is that there is definitely optimization of what people are doing. So our same, routing announcement points result in different views in the world. So clearly, people do, just as Jeff was indicating, change their routing policies based on, root server related announcements. I don't know why. Jeff has a good theory. I also encourage you to come. So A, my ask is, have you asked other root server operators for information? And B, I encourage you to come to my lightning talk tonight titled, "You Don't Need to Talk to the Root Servers Anymore."
Thank you. Thank you for your comment. Thank you.